Hey team, today we're going to look at a skill factoring quadratics using an area model. Let's go ahead and dive on in. All right, so this is a core concept that you're going to need to do throughout the course, and it's basically to figure out the x-intercept or the zeros of a quadratic. You need to factor it. So what I like to do is I like to use an area model. This helps organize your thoughts and kind of figure out how this is achieved. So x squared will always go on the top left, and negative 13 is going to go on the bottom right. The reason I put these there is this is my leading term, x squared. This is my last term, negative 13. Now you might be asking yourself, where do you put the 12x? Well, this is where the puzzle comes in. 12x is going to come from a combination. It's going to come from this area created from multiplying, and then this area from interactions that I'm about to describe. So the first thing you got to ask yourself is, this is x squared. What multiplies to be x squared? Remember, x squared is the area. To find the area, you have to multiply the length times the width. The length of this is going to be x and x. X times x is x squared. This is the only possibility. I'm going to do the similar thing, but I'm going to keep in mind the factors of 13. Factors of 13 are 1 and 13. But it's actually a negative 13. So I have to have one of them be negative and one of them be positive. 13 is prime, so those are the only possibilities. Now think about it. I have to figure out what numbers are going to end up being 12x. If I wrote what follows, I would say negative 13 times 1 is negative 13. Opposites are equivalent. This is the same thing as saying this is negative 13 and this is 1. 1 times negative 13 is negative 13. You see how the side links are what's producing the area? Using this, you're going to then figure out, well, this extra bit. What is x times negative 13? Negative 13x. That comes from yellow and blue together. What color does that make? Green? 1x. Now, I do want to point out that this answer, what essentially we have discovered, is that x plus 1 times x minus 13 is equal to x squared minus 13x plus 1x minus 13. And if I simplified it on the right side by combining like terms, I would get negative 12x minus 13. So this is actually not the answer I want. This is not the expression that was listed. This does not produce it. If you look at it, x squared and x squared work, negative 13 work, but because of the way I arranged it, it does not form negative 12. Or it needs to be positive 12. By simply modifying it slightly, normally you would just kind of erase the insides, but I'm trying to show you, x squared negative 13. You might ask yourself, what could you change? X times x is always x squared. But if I made it a positive 13 times a negative 1, notice x times x is x squared. Negative 1 times 13 is negative 13. Then I multiply out 13x negative 1x, and this is a result of me multiplying the other sides. Notice you can see the green portion, 13x, and a negative 1x is going to be 12x's. This is an indication that this is correct. So, lo and behold, this quadratic would be x minus 1, x plus 13. This is the final answer. If you want more proof of it, over here, you can distribute it yourself. X times minus 1, x plus 13. It would multiply out to be the same. If you wanted to do it algebraically, it would show you that you would get minus 1x plus 13x minus 13. Notice how this is the same as the area method I showed, multiplying it out. Either one works. Okay, let's do the second one a little quicker. So x squared minus 16x minus 36. I see that it's a quadratic, so I'm going to go ahead and use my area model. And I'm going to go ahead and do as follows. X squared goes in here. Negative 36 goes here. This is going to get you started on your journey. So now you're going to ask yourself, well, what multiplies to be each part? I have to figure out negative 16x is my goal. Well, lucky for me, x times x is the only possibility to get x squared. How do I get negative 36? Well, I can go ahead and try negative 9 times positive 4. When I multiply it out, negative 9x and 4x is going to be the result. Now, I'm going to go ahead and write it out, but this is something you can get just by looking at it. Evaluate the inside area. And after you combine like terms of the 2 in the inside, it is negative 5x minus 36. Do you see how this does not match? This is not what I want. So it's like, okay, back to the drawing board. I'm going to try this again. I'm going to go ahead and I think I know what it is. I need to flip the negative. I'm going to make this be a positive 9 and this be a negative 4. Let this be an x and this be an x. Notice x times x is x squared. 9 times negative 4 is negative 36. We might be on to something. 9 times x is 9x and negative 4x. This time I'm only going to look at the green region and think in my head, what happens when I combine them? Oh, it's 5x. Dang it, it is not negative 16x. So this isn't the factored version. So you're going to be thinking, well, what negative 36? I've tried 9 and 4. I've tried various combinations. I've done one where it's negative, one where the negative is on the 4. What are the other math facts? Now, there are other options. There's actually quite a few. You can do 1 and 36, 2 and 18, 3 and 12. And notice what happens when I'm just writing them in order. 4 times 9, and then 6 times 6. What I'm going to do here to kind of guide my thinking is figure out what combines to be 16. And do you see how 18 and 2 could be made into 16? It's the only possibility. So this is going to guide me for my final one. What's constant is first term, last term, I'm going to go ahead and think, well, x times x is x squared. And I know that 18 and 2 need to make 36. I need it to be a negative 16 is my goal. So I'm going to go ahead and make the 18 the negative part. When I multiply it out, it's going to be negative 18x. It's going to be 2x. And voila, I can look at the inside and see that x squared minus 18x plus 2x minus 36. And after I combine like terms, I get the exact copy that I want. This is what I'm looking for. So my factors are going to be x minus 18 and x plus 2. Where did I get that from? Well, looking at the sides. X minus 18. Look at the top. X, what type of 2 is it? Oh, positive 2. All right. Essential skill using an area model to factor quadratics. That's it for now.